Okay, we've got recording going. I'd like to welcome everyone to Altinity Quickstart for ClickHouse, creating your first application. What we're going to do in the next 60 minutes or so is we're going to give you all the information you need to go, or that you need to have to build your first application using ClickHouse database. My name is Robert Hodges, and I'm CEO of Altinity. This I've been working with databases for many years, and it is a pleasure to be able to give this presentation today. Let's do a little more introductions. First of all, we come from Altinity. We offer ClickHouse support and services, including Altinity Cloud. We wrote the Altinity Kubernetes operator for ClickHouse and a number of other open source projects. We've been involved in ClickHouse for over 5 years at this point. As far as our team, we're database geeks. Together we have centuries of experience in database and applications. For myself, I've been working with databases since 1983, so it's getting on to 4 decades. Pretty long time to be using them. You as the audience, we're focused on application developers who are looking to learn about ClickHouse. We assume that you have some background with databases and that you're somewhat familiar with them. And of course, we assume you have some development chops and know how to put applications together. What we're going to do is supply the extra information to apply your existing knowledge to ClickHouse. So what I'd like to do is start pretty basic on this. By the way, as this presentation goes on, if you have questions, feel free to throw them into the chat or into the question and answer box. We should have a little bit of time at the end to cover them, and if they're directly relevant to the conversation, I'll cover them as I go along. So let's start with what's a ClickHouse. So ClickHouse is a SQL data warehouse, and what that means is it is a database that is designed to read data and give answers very, very quickly. And it has a number of properties that it shares with some but not all other data warehouses. One is it understands SQL, which is sort of the winning language for queries. ClickHouse is interesting that it's very portable. It runs on everything from bare metal to cloud. It has what's called a shared nothing architecture, which means that it's a bunch of nodes with attached storage connected by a network. It is moving toward a decoupled architecture where compute and storage are separate, but that's an ongoing process. Like almost all data warehouses, it stores data in columns as opposed to rows. We'll talk about that a little bit in a minute. It has extremely efficient execution, both parallelized across many nodes and then vectorized, which means that it can exploit the parallelism available on CPUs. It will work on your laptop, but it can scale to tens of petabytes in huge clusters. The largest clusters have hundreds of nodes, and it's open source. It's permissively licensed under Apache 2.0, which means you can use it anywhere for any business purpose. And what's happened is ClickHouse has been so successful, it's evolved into what we might call the core engine for real-time analytics. Real-time analytics means you're building analytics where you need to either react to information very quick, that as it occurs in the outside world very quickly, or provide instant answers to potentially complex questions. Either way, it's real time. Sometimes many of the applications combine both of these things. And so we have data feeding in from event streams, ELT, object storage, coming out to be consumed in dashboards, interactive APIs, as well as other types of ways that the data can be used. So this is the ClickHouse SQL data warehouse. It's useful to just take a minute and talk about what ClickHouse is not. It's not MySQL. MySQL is great for running e-commerce sites. Of course, it underlies countless applications worldwide. ClickHouse doesn't have a full ACID transaction model. It's also very slow on updates, so you can't use it to run an e-commerce site. You would lose money, and it wouldn't have the ability to make the changes fast enough. We'll talk about that in a little bit. It's not Snowflake. Snowflake is a cloud data warehouse. It has an extremely complete SQL implementation. ClickHouse as a product values speed over SQL standards, and it runs anywhere. So it's not that we lack SQL, but we may not always do it in exactly the standard way yet. Finally, it's not Redis. So Redis is used as a front-end cache. It's also used for things like shopping carts, where you have potentially hundreds of thousands of concurrent users who need to get answers very quickly. ClickHouse is designed to read very large blocks of data, not small things, and to do it for a relatively small number of users that might be in the hundreds, but not tens of thousands. So how does ClickHouse do what it does well, which is to read data? So 3 things. It stores data in columns. And this is really important because what it means is that if you have a very large table, and in fact ClickHouse is designed to permit tables to have hundreds or even thousands of columns, you only need to touch the columns that you're actually asking questions about. This is unlike a row database like MySQL, where if you reference 3 columns, you're going to read the data for all of the columns in order to answer that question. So this columnar storage is extremely efficient. It's also coupled with a couple of other features. First of all, compression, and second of all, parallel query. So what I'd like to do is I have an example here of the effect of columnar storage going all the way to parallelism, and what kind of difference it makes in the amount of data that we need to scan. So for example, this big ball on the left that volume represents reading all columns in a row database that's storing 59 gigs of uncompressed data. This was based on our on-time data set. Now, if I run a query which just references 3 columns, all of a sudden, instead of in that particular data set I have 109 columns, all of a sudden I'm only reading 3 columns, 3% of the data right there. It just happens that's exactly what it turns out to be. Moreover, that data is incredibly compressed. So those 3 compressed columns, in fact, the actual data that was stored on disk was 21 megabytes. So we're already down way below, we're down to 3/100ths of a percent. Moreover, because we can parallelize on the CPU, we can get 8 threads, hardware threads, to go ahead and read that data. Each of those only has to read 2.6 megabytes. The effect is that the amount of data that each thread may read when we're scanning a table to read the contents of all 3 of these columns is reduced by a factor of tens of thousands. So this kind of efficiency means that ClickHouse can answer questions that require us to scan sometimes trillions of rows, but it can answer them in many cases in less than a second. And it's because of the parallelism and the fact that the data that we have, we minimize the data we touch, and the data that we do touch is very, very small. So that's ClickHouse. I won't give you any more marketing information. What we're going to do now is dive in and figure out how to install ClickHouse and connect to it. This is our first step. So let's just jump in. And by the way, people have joined. Feel free to ask questions. Pop them into the chat or in the question and answer box. We'll catch them as we go along or at the end. So back to installing ClickHouse and connecting. Okay, there's a couple different sources now for ClickHouse builds. The traditional source is ClickHouse community builds. Go to the clickhouse.com site, which is where they're hosted, and there's a couple different kinds. There are monthly builds. So every month ClickHouse has a new branch which is going to be versioned, something like, for example, this is January, so this month's build is 22.1. So first month in 2022. Every 6 months, the ClickHouse team has what's called an LTS release, so a long-term support release, and the community supports it for 1 year. The next LTS build is scheduled to be in March, so it will be 22.3. And you can count on those having about a year of support. The other source of builds is Altinity stable builds, which we produce. Unlike the community builds, we don't try and do a build every month. What we instead focus on is just building the LTS builds, and only when they're prod ready. And so if you pull an Altinity stable build, you have a build which we've certified is ready for use in production. We also give at least if it's a recent one, we'll support it for up to 3 years. You can find out about those at docs.altinity.com. Either way, once you point to the repo, you can just go ahead and use something like apt if you're on if you're on Ubuntu, Red Hat has Yum, so on and so forth. And in a couple of commands, you have ClickHouse up and running. It's important to note that it's always two commands to install ClickHouse. One is to get the software, and then the second one is to go ahead and start it. And this is because ClickHouse lets you decide when you actually want to start the server up. It makes upgrades easier. So that's how to get the raw software if you're running on Linux. This will work great on your laptop, on VMs, so on and so forth. Another popular way to install ClickHouse is to use Docker. So for example, if you're on a Mac and you don't feel like taking the trouble to install it locally, which you actually can, you can go ahead and run Docker. Again, two sources for the Docker containers. Traditional source is Yandex ClickHouse server. That tag is left over from the days when Yandex was building this. You can go ahead and pull that, or you can pull Altinity ClickHouse server. Either way, with a single Docker run command, you can go ahead and bring it up. What I show here is I'm doing making a directory for my ClickHouse data. I'm then going to go do Docker run, and I'm going to use a -- volume option to map it to my disk so that I can actually see the data. The other thing is I won't lose it if the container somehow restarts. So and I do port mapping, include the number, set the number of open files, things like that. This single command will bring it up and running. In both cases, both Docker as well as installing, if you have a good network connection, you're up and running in about 60 seconds. Final option. If you don't feel like running it yourself, you can just run it in the cloud. There's a couple of obvious places that you can go to right now. Altinity.cloud, which we run, has trials. You can get one of those spun up in a couple hours and be out and working with ClickHouse. Second service in Eastern Europe, a number of people use Yandex, which has a managed service for ClickHouse. There are others on the way in later versions of this class. We will of course update them. So lots of options to work with ClickHouse and actually get it into a place where you can run it. Let's look at connecting to it. So there are many ways that you can connect to ClickHouse. I'm not going to go into all the tools. I'm just going to talk about two really simple ways that just work out of the box. The first is ClickHouse Client, which is a command line or CLI that talks to ClickHouse. If you install ClickHouse on your laptop, chances are you can just type ClickHouse Client and bang, you'll be connected. Now, what was it really doing? Well, it was actually doing the second command, but filling in the options for you. So the host was localhost, so whatever you're running on. The port is 9000. That's the standard port for ClickHouse Client to use. It has a special, it's used for what's called the native TCP protocol, and then it has a user call default, which always exists in new ClickHouse servers, and it doesn't have a password. So you're connected. If you are connecting to something running in the cloud, the command is going to look more like what we have down below. So we'll give a host name. In this case, it's GitHub demo altinity.cloud. This is a real host. You can go try it. Port is 9440, and it's TLS encrypted, so secure, and then demo, and demo is the password. If you type this command, you will be connected to a ClickHouse server immediately. And then finally, there's a really super web UI for just quickly logging in. You don't have to install any software. You can run this if you have a browser and you can see the server. It's called the Play interface. And the way that it works is you just give the host name, the port, which is 8123. This is an HTTP port that is by default open on new ClickHouse servers. This one that we see right here is just connecting to the laptop, and here's an example with HTTPS down below, again connecting to that same GitHub data that's hosted out on Altinity.cloud. So these are two ways to get into ClickHouse. Excuse me. And at this point, you're connected, and you can begin to attach to ClickHouse and look around. So that's the next thing that we're going to talk about, which is finding your way around ClickHouse. In a nutshell, ClickHouse, just like virtually every other self-respecting database, it has databases and tables. The organization is pretty much like MySQL. So in MySQL, you have databases, which are basically folders, and then you have tables that live within them. And if you go out onto the file system, that's literally how they're organized. That you see a directory which corresponds to your database, and then each of the tables is a directory underneath that. If you're a Postgres person, they're like schemas. They aren't like Postgres databases. There's a big distinction there. In Postgres, databases are independent things. You connect to one at a time, and when you're connecting to one database on your Postgres server, you can't see any of the others. So ClickHouse databases, they're just like folders. And every connection to a ClickHouse database has a current database. So, and we'll talk about this in more detail, but basically, if you're connected to that current database, you don't need a database name because your tables will all be referenced automatically. We'll show an example of that. Commands for navigation. If you're a MySQL person, you're going to fall in love because it's really simple. So, show databases, for example, is going to list your databases. Select current database. That's going to be, hey, where am I now? What database am I actually connected to as my default database? Show my tables. If you don't say anything, the local ones. You can add from and give another database. You can describe a table. That will show you the organization of it. And then just a couple examples of SQL commands. If I say select count from on time and I don't give a database name, it's going to look for table on time in the local database. If I do give a database name, as we show in the last example, it's going to go ahead and select it from that database. So there's also a use command. This is very similar to what you see in actually the Sybase used to support this, so this goes back a long way. If you say use system when you're connected with ClickHouse Client, that's going to change your default database or your current database. Now, when you're using APIs to connect, in general, they're going to require you to say, hey, what's my current database, and they're going to go ahead and set that for you, and you won't be able to switch it around. So this use system command, it is not a SQL command. It's actually something that the client has to know about. And finally, just one thing that's really important to understand about ClickHouse is when you log into your new ClickHouse server, there's always going to be two databases that are there and ready for you. Default, and that is is going to be your current database whenever you just log in. You can, when you're starting up, that's probably where you'll end up putting tables. You can make more databases if you want, but that one is always there and available for you. And then there's another really important database called system. And this is, as it sounds like, it's the system tables. This is all your metadata about what's going on inside ClickHouse. These are incredibly useful. We'll only touch very lightly on them, but they tell you everything from what's your level of compression to what's going on in the log. You can configure them so that, for example, you can get logging information, you can see records of queries. They are incredibly powerful, and in my experience, they are the best system tables I have ever worked with. Really easy to understand and very accessible. We'll show a couple examples as we go along. So what I'd like to do now is actually get into the guts of using ClickHouse. What we're going to do is go ahead and create a table and show how to load data into it in different ways. So here's a create table command. So if you're coming here and you haven't seen SQL before, this is a standard command to create a table. ClickHouse is a little bit different because traditionally, and in fact most of the versions that many of the versions that you'll likely be using, it supports these special column types. Int 32, we would normally just say int if we were in other SQL data warehouses or databases. That's actually been implemented in ClickHouse so that the ANSI types should work in more recent versions. But these are your table columns. So you have your name, you have your type. It's all pretty straightforward. Yes, the types are different, but you get used to them in about 3 minutes and you're ready to go. There are one thing I should mention is that ClickHouse has very good support for types like arrays, for maps, so structured data types. We're not going to talk about those in this talk, but they are there and they're very powerful. What is very important to notice right from the start is that ClickHouse has some table properties that are not the same as other databases. For example, there's this engine command. Looks a little bit like MySQL, if you remember engine equals NODB from those days. we have an engine called MergeTree. And we're going to talk a little bit about what this is, but this is basically the workhorse engine for analytic data in ClickHouse, and we'll describe its properties in a few slides. MergeTree tables are broken up into what are called partitions. So this is basically separating the data out into groups. It makes it easier for ClickHouse to decide how to divide the data up, because our data sets are very, very large. We can't have, what this does is it creates parts. Parts, they can be pretty big, like into hundreds of gigabytes, but they can't be infinitely large. This tells ClickHouse where to make breaks. And then finally, how to order the data. And so this order by, this is very important in columnar databases. We do order all of the columns, so we need to make a choice up front. And we also use that to build what's called a sparse index, which enables us to find anything that is referenced by this column dev ID and column mDateTime. We'll talk a little bit more about that in later slides so that this will become clear. Let's look at inserting data. Well, the traditional way to insert data is to use a SQL insert command. Here's an example. So if you're insert into SData values and then you give some tuples, if you're used to running that in MySQL or Microsoft SQL Server, it works here as well. Pretty much the way that you would expect. The thing is that in real ClickHouse, not many people actually do it this way. Because we're dealing with very large amounts of data, and we really don't want to spend a lot of time turning everything into this SQL statement. So what we in fact do is use input formats that allow us to log data in their raw forms. So for example, values is an example of an input format, but it says, hey, I'm going to look past the end of this and you'll see tuples on the command. But we can load CSV directly, for example, just raw CSV or CSV with column names. We can load JSON. There's a bunch of different ways you can load JSON. The most popular is to have a single JSON document on each row. We can do protobuf, Avro, Parquet, Orc. There are literally dozens of these. So you can go, and this shows where the docs are. You can go look them up and see which one is suited for you. So really good chance that, for example, if you're loading Parquet, you can just load it straight out of the Parquet file. You don't need to. All you need to do is pump it in. So the question is, how do you do that? And it turns out that ClickHouse has a number of ways of grabbing these files. So the simplest way, and when you're starting out, if you just want to get some data, you've got data in files and you want to get it loaded quickly, a very simple way to do this is to load it using ClickHouse Client. So we're going to, here's my file, it's sdata.csv. You can see I've got my column names on the top in the first row. And so what I'm going to do is I'm just going to pipe it into the ClickHouse client, working on the command line here, send it to a database called Sense, and here's the insert command to tell it what to do. What's kind of nice about this is I don't even have to tell it what columns I have. It's actually going to go ahead and read them and correctly assign them from these column names on the first line. If you don't want to do this, or ClickHouse Client is not convenient, you can also load it with an HTTP post command. This is another really cool feature of ClickHouse. It has basically a web service API, which is simply based on HTTP post and get. So here what we do is we're going to, and this is doing it in Bash, we're going to go ahead and create our query with nice URL encoding. And then we're going to stick it on the end of the URL, and that query equals, and we're going to put that value in. And then using curl, we're then going to include the body of our data inside the post request that gets sent off to ClickHouse. So this works perfectly well, and every single format, you can use it to load data of any types. Of course, you can drive this through JavaScript or Python or whatever, but it's really handy for loading data. Another way to get data in, if you want to load it quickly because you're starting out, is to get it from S3. So what this does is we use a form of the insert where we insert into SData, but instead of values, we're going to say select, and we're going to select star from, and this thing that we're selecting from is not a table. we could actually select from a table. That's a perfectly good way to load data. But if we don't have anything there, what we want to do is use a table function. That's S3, and that says that's a function that returns tabular output. And in this case, it's going to go get it from S3. And you can see we've got a nice long URL here. We're going to include our access key and our secret key for Amazon. We're going to give the input format. And in current releases up through the end of last year, you also had to give the schema. Sort of painful because, as I showed before, ClickHouse Client, for example, can already figure this out. But you have to give the schema. So even if you're reading something like Parquet, which actually knows it already, or CSV with names. As of 22.1, which is this month's release, that's no longer necessary. One important thing to note about loading from S3, you can read multiple files at once. So here you have this S data. You can pull this in using a wildcard. In it comes, there is this max insert threads equals 32. What that's saying is allocate 32 threads and load this data. One thing to look out for is this kind of parallelization. If you parallelize with this, it makes the loading incredibly fast. Like you can literally load millions of rows per second from S3, but one thing it will do is it'll use more memory. So you may occasionally run out, in which case you either bump the memory up available to queries or you reduce the parallelism. So that was inserting rows. You may wish to update or delete them. This is a place where ClickHouse, again, is very different. It doesn't have yet a SQL delete command or a SQL update command. Instead, we use a form of alter table, and we do it asynchronously. So these are just examples. They look similar to update and delete commands, but what's happening is when you issue these commands, it will return instantly, and it generates what's called a mutation. A mutation is a command that is going to run in the background, and ClickHouse will just schedule it, and over time it will get done. If you have a powerful database and you're not changing very much, it will get done almost instantly. In extreme cases, it could take hours to complete. And the reason that it takes a long time to complete is it's actually going to have to rewrite data. We'll show that in example in a second. So it is possible to find out when these are finished. A very common command that you're going to do is when you run these, if you're doing a change, you can use the system.mutations table. Here's our first example of one of these great system tables, and you can use that to find out what's the status. Once they say is done, they're finished. You can also, every now and then, one is going rogue or is just not finishing, you can kill it. This will usually knock it off. It may take a little while to stop, but this will stop it if you need that. So it's worth talking a little bit about what's going on inside ClickHouse, because these things are kind of different from other databases. So I mentioned that we had parts. Here's what actually happens if you look at the database. The database is going to be divided up. You'll find that, the table is going to be divided up into parts. Each one will be in a separate folder. And within the parts, they all belong to whatever that partition value is that you set in partition by. So for example, all your January data would be in a single part, or set of parts, but it would be only January data. And they have columns, which are going to be sorted in the order that you gave in your create table. They also have this thing called a sparse index. So that is, and we'll show the details of this further on, but basically it has an entry for, by default, every 8,192 rows, and it allows you to reference blocks of data quickly as long as there's something that's in the index key. So this is what's going on down there, and every time you insert, it will generate a part. Now, what happens though is that those parts can be kind of small. So they might be 10,000 rows, they might be 100,000 rows, they might be a million rows. That's still small by ClickHouse standards. So what ClickHouse does in the background is it really wants those parts to get pretty large, like to many millions of rows, extending up to say 200-300 gigabytes in some cases. So what ClickHouse does is it merges them in the background. You write your parts, you're going to go ahead and insert them. In the background, ClickHouse will look over them, and from time to time it'll run a merge, and it'll take smaller parts that have the same partition key and it will merge them into a bigger part. Why is this important? It reduces the number of files that we have to read. It gives you longer run lengths for compression. It has a number of benefits that mean that ClickHouse can then do reads faster off these parts. Important point, when you do updates and deletes, they have to actually rewrite the parts. So they tend to be, updates will only rewrite the columns that they affect, but they can delete, for example, when you're removing rows, has to rewrite the whole part. So that requires the same process, and that's one of the reasons why they're asynchronous now. So here's some tips. If you're new to ClickHouse, new things that you should do. You want to pick that partition by, it's important. You want to pick something that gives you nice fat partitions. Here's some guidance. Make sure you end up with less than 1,000 parts. It's easy to find out. There's a table called system.parts. If you can't decide, partition by month. That's the most, in fact, ClickHouse used to default to that very early on. That's a good thing to get started. If you have time-based data, it won't be that far off. Second thing, use input formats to load that raw data directly. Don't generate a bunch of inserts statements. And finally, insert large blocks. And when we say large, we mean really large. You can insert tens of millions of blocks simultaneously. ClickHouse has no problem with it. In fact, it's more efficient because it requires less merging afterwards. So by large, if you're inserting single rows, you're going to die. That ClickHouse will just collapse because it has to keep, every one of those rows will generate a block. It has to get merged. As more rows arrive, you have to remerge. So that's not what you want to do. So make those blocks large. What that usually means is you have to buffer data a little bit. If you're reading it out of Kafka, for example, wait for a couple seconds, let a few million rows come in, and then blast them into ClickHouse. With these, there are many other ways to things about table design and data loading, but these three will get you a long way. Let's talk about selecting data, because now that we've got the data in, it's time to get it back out again. So select is where we start to harvest the benefit of having loaded all this data. So for example, here's some cool diagrams. These were done in preset, which is the hosted Apache superset. Really cool superset, a really cool dashboarding tool. So this shows the number of the air traffic flows between different large airports and then the busiest airports. This is the visualization that we want to achieve, but to do that, we're going to have to select data out. So let's go ahead and look at how to do that. Here's a select. So I'm going to assume everybody on this call has seen SQL once before, but here's all the basic stuff that you expect in SQL selects is there. So we have carriers, and because we're using an analytic database, we refer to these columns in a different way. We're going to talk about what are called dimensions. So a dimension is data that characterizes the question or the thing that we're querying. So for example, carrier and year, we're going to group the data by, when we count things up, we're going to group them by these dimensions. We also have the things that we count, those are called aggregates, and I'll use that terminology pretty consistently here. We have sum, and we have so we're adding up the values of a field here or a column here, and then we have count. Those are just two examples. We also have range. We can filter data. So we use a where clause for that. Group by, we talked about. Having is something that allows you to filter on the values of aggregates. So once the aggregates are computed, if they don't match that this having, they can get knocked out. You can order the data. So this is something like, what order is it going to come back to you after it's been processed? And then finally, really important in analytic queries is you'll use limits, because many of the queries can potentially return millions of rows, but if you're in many cases you're just interested in a few of them, and the limit will help you do that. We'll see an example in a minute. So if you've seen SQL before, this is pretty standard stuff, and in fact this exact query would probably run just fine in most databases. It runs in MySQL. So far so good. So what you can do is, if you're familiar with SQL, you can basically just try it out in SQL in ClickHouse, and the chances are it'll just work. Question is, what's different? So let's spend some time on that. First of all, if you're using ClickHouse and you have large data sets, there's a really good chance you care about excuse me. Sorry about that. There's a really good chance that you care about time, and we have what we call time series. Oh, let me just getting some information here from okay. Sorry, just getting some pop-ups coming. Time series. So it's data with built-in time ordering. This is really important in large data sets because they're almost always based on facts of some kind. Those facts are associated with time. There's a really good chance that you care more about more recent things, or that you're asking questions like what happened over time. This is an example. So what we're going to do is very commonly run queries that have time dimensions in them. So for example, this query shows us taking the date of a flight, this is airline flight data, and normalizing the flight date to the start of the week so that everybody in the week will have the same value. We call that the week, and then we're going to group by that. And that's how we get the kind of information that you just saw in that query visualized in that display on the previous slide. So this is a kind of query that's exceedingly common in ClickHouse, and ClickHouse for that reason has really great support for managing and querying time. So we have three data types. We have the date type that gives you precision today. That particular data set we're working on uses that. A very common one is the standard Linux date time, which is precision to second. And then a recent addition over the last couple years, proud to say put in by our guys, is datetime 64. That gives you precision down to nanoseconds. So those are your column types that you can choose from. On top of that, you have a raft of support in the form of functions that can do various transformations on date, datetime, and datetime 64. So for example, in the previous let's see, we had to start of week. We don't cover that, but you can normalize the start of year. You can turn things into hey, what's the date? Go down to seconds. All kinds of great transformations that are available to you. Just look them up. They will help you construct whatever query you want to do. The other thing that ClickHouse has is really great aggregate functions. In a standard SQL database, you have 5. These are the ones defined in the SQL standard. You will also, sorry about these notifications. You will also have many, many more, which let's just pick one, unique. That's the number of unique values. So for example, you can use that to help you compute the number of unique visitors to your site over per unit time. That's a very common one. You can do quantiles, you can do linear regression. There's also this any function, which is kind of interesting. Some databases support this. Let's just, I'll show an example of it in a minute. So here's drilling into this group by syntax and using these aggregates. So again, you will have the dimensions, which are the things you're grouping by. These are the characteristics of your data that are important for you and for which you want to count things or otherwise aggregate them. So we're using carrier and year, and then we're going to count the number of total flights and the sum of the canceled. So anything that is not a group by is going to be it has to be an aggregate. So it needs to be one of these aggregate functions, otherwise you'll get a syntax error. So another example is that shows the effect of these aggregate functions in a more interesting way is what's called a top-end query. This is a really, really important query that you'll use constantly, particularly for things like dashboards where you're showing, hey, who are my top customers? Who are my slowest queries? What are the pieces of software that have had the most failures of a certain kind? So this kind of top-end query uses limit and order, descending order. And here's an interesting use of aggregates here. This one's called any, what this does is it basically allows you to grab correlated values that correlate to this dimension value. So this is helpful because in ClickHouse tables, it's very common, since there's no cost to having extra columns, we denormalize, and we include like the origin city name for flights, and we can just grab that and include that extra data. But it has to be use an aggregate, and that's what any does. It just grabs one. Okay, let's talk about joins. So in many ways, joins look identical to joins in any other database. This syntax would work just fine. Well, I don't know about the any, but this would probably work just fine in MySQL. And what we have is, we're going to collect data from on time. So these are our list of flights, and we're going to join it with the airports to get the airport name. And so we have a left join. This is a common type of join. It says, hey, the left side table is on time. Let's include the on time data even if we can't find the airport name, because we might be missing something. There's no, incidentally, in ClickHouse, like many analytic databases, there is no referential integrity between tables, so this kind of left or right join becomes quite important. So let's have a look. Oops, looks like we've got a little bit of a rendering problem here. We'll look at this in detail just because it is important to understand, particularly because of the way ClickHouse processes joins. So going in detail, you can look at this and you see that we have the left side table, which is on time, joined to the right side table, and then here's just your different left and right joins. These are sometimes called a left outer join or a right outer join. The inner join only includes rows that match. Full outer join includes everything, including non-match rows, and cross join. These are standard join types that are present in just about every database. So ClickHouse does support these, and if you're curious about all the how they work, it's really easy in ClickHouse to just set up some little tables and check them out yourself. Here's an example that I use to make sure that I'm not getting left and right mixed up. So ClickHouse does this fine. What is different about ClickHouse is the following. ClickHouse doesn't really know how big the tables are. Well, that's not totally true. It does know, but it doesn't use that information. So ClickHouse is basically, when it processes that join that we see, it's going to go through 3 steps. This is leaving aside parsing and stuff like that. The first thing it's going to do is it's going to go find that right side table in the join, and it's going to load it into memory. So it will filter it if it can. It can apply some predicates to it, but basically it's going to construct a hash table in memory. And then what you can do is you can have the left side table, and this only allows you to do what's called an equijoin, where you're actually where the values equal each other. What it will do is, once it's got that table in that right side table in memory, it will now do a parallel scan of that left side table. So what we hope is that left side table is big, because that's where you're going to get your parallelization, and as it runs down that join, it's then going to, as each hardware thread is reading data, computing aggregates, it's also going to look across and then grab data out of that in-RAM hash table and add that to the results as it goes along. And then eventually all the threads, their results will all get brought to a single point where they will get merged. So for example, the aggregates will finally get each thread computes part of the aggregate, and then they'll all get combined together into your final answer, sorted, and then handed back to you. So the effect here is that you want the left side to be your big table. That's where you're going to get the power of ClickHouse with all the parallelization and the effects of reading compressed data. The right side table, and you can have more than one, ClickHouse is perfectly happy to join against multiple tables. Those need to be small, and they need to fit in memory. So this is a place where ClickHouse does differ from other databases. You need to make some choices. The nice thing is it's not very hard to understand. So here's some tips for querying data with ClickHouse. Use the time functions. So you tend to be, every now and then I see people selecting, just selecting raw data out of ClickHouse. It's pretty rare to do that. sometimes you may do you may be doing it because you're looking at the source that generated an aggregate, but what you want to do is typically ask a question where you're counting something, often by some unit of time. So those time functions are there. Similarly, you don't want to pull data out and aggregate it yourself. Use the aggregates to summarize the data inside ClickHouse. ClickHouse can do this vastly faster than almost any application. And then finally, if you're doing joins, the big table goes on the left side of the join. That's really important. Otherwise, you'll run out of memory or just have other unfortunate side effects. Eventually, we hope this year, ClickHouse will be able to start applying some of the information that it possesses, and it will set the join order automatically, and this will become less important. Speaking of performance, the final section here, we're going to talk about some self-defense on performance. ClickHouse is out of the box really fast, but it doesn't hurt to do a few things that will help it go even faster and begin to get you some of the legendary performance. Let's look at them. So 4 easy things you can do. Add more CPU. Be careful what you ask for, so limit your columns and rows. Do some simple fixes on table design, and then more complex, storing data more efficiently on disk. And I won't tell you how we're doing it because we'll show it in the slides. So adding CPU is really simple. ClickHouse, by default, it has a property called max threads. In a new server, by default, it's half of your available hardware threads. And so if you see a query that's not going fast enough, one of the simple ways to try and goose it up is to bump up your max threads. So this shows the set command. This is doing it in a session with ClickHouse Client. Go ahead and set it up. And this graph over here shows the effect of different numbers of threads applied to the query. And what you can see is bumping it up sometimes will give you a big jump, and then at some point you'll start to see things like merging and sorting, which have to be basically can't be parallelized as well. Then the payoff for adding more threads tends to decline as you get larger numbers. One other thing about max threads is as you increase the number of threads, it will increase the amount of memory that your query uses. So the trade-off here is you might run out of memory. But it's a simple way to goose things up, and sometimes it's exactly the right thing to do. Another really simple thing is just to read fewer rows. So here's an example of just using a, where we have a where clause and we're trying to restrict this down. And basically, for reading a single table like this, or a table where you're joining to some small things, the query performance is going to be dominated by the amount of data that you actually read. We call it marks. I'll show you what they are in a second. And here you can see an example of the amount of marks. These are blocks of data that we had to read. It correlates directly with the time that this query requires. So it's as simple as that. We're scanning the table, so the less data you scan, the faster you go. It's useful at this point to understand a little bit more about what's going on inside MergeTree. This is the final bit of plumbing that's helpful to understand. I mentioned that ClickHouse has tables have this sparse index. It's a file called primary.idx. The reason that it's sparse is that it just has an entry for every 8,192 rows by default. And what ClickHouse will do is it will use this to locate rows if it can, but within the columns will then have what are called marks, which correspond to granules of data. So they roughly correspond to compressed blocks, but the compressed blocks actually have more than one granule in them typically. So, but the point here is that when you select something in ClickHouse, you're going to go out and find the compressed blocks, and then you're going to go ahead and read them. So ClickHouse, one of the reasons why ClickHouse can't read small amounts of data easily is because these blocks tend to include 8,000. These granules are going to include 8,000 rows. So if you run one row, you're going to get 8,000 at the same time. That's why we don't use ClickHouse to run e-commerce sites. So one of the things that's important is to try and make these compressed blocks as small as possible. So that's definitely something that we can do. and there's a variety of ways that we can help make this more efficient. We'd also like to have fewer of these files lying around, so we want to have the parts be as large as possible. Let's look at those two things. So table design. This is where I said that table design we would come back to, and we'll look at these partition values and then primary key and order by. So partition by breaks the data up into parts. So in this particular data set that we're looking at, if I partition by year, it's as it turns out, it's a number of years of data. We end up with about 125 parts. This actually is less efficient than what I would expect. These parts are kind of small. We could probably make them larger, but the point is that you have parts which have 107 megabytes. And this is like, for a large data set, you would actually want to have parts far larger than these. So you want to make sure that you're partitioning by some value that's going to make parts be pretty beefy. Second thing is the primary key. If you have columns that you particularly filter on, it's really good to have them in this primary key. So that's the carrier and the flight date. And then finally, you order the columns, because this is your sorting order, and the first part of the order has to be a prefix of the or it has to be the primary key order, and then but what you do is the columns need to be ordered by the increasing cardinality. In other words, the number of values. So for example, we could go from carrier, which has a small number of values, to flight date, which has a larger number of values, to departure time, which has an even larger number of values. So you order them from left to right. This is just standard way of setting this up. And cardinality, if you aren't familiar with that term, just means how many unique values there are. So that kind of table design will help make things more efficient. You can also equally important, set the column compression level. This will make those granules we just talked about smaller. And there's another great system table, system.columns, which shows us the exact compression levels. So it's really easy to find out how efficiently you're storing the data just by running this query. And you'll be able to get this off the slides that get sent to you after this if you don't know it already. So there's two things we can do. We can change the compression. By default, ClickHouse comes with LZ4 compression. It's really quick to compress and decompress. You can also use ZSTD. It's a little bit more expensive to decompress or to compress, but it generally gets smaller results than LZ4. You have to specifically ask for it. And here's a value tail number, and basically this would take these bits without knowing anything about what they mean, and it would reduce them to a smaller size. So changing compression is one thing we can do. The other thing is adding a codec. So an example or an encoding. An example of this is low cardinality. This is actually looks like a data type or a function that you call on the column value or column type. It turns a string into what's called a dictionary encoding. So say you have a string like airport or tail numbers where there's a few thousands of them but not a huge number. What it will do is, instead of storing N86-2A, it will go stick it in a dictionary with an integer value which is smaller, and then we can apply something like ZSTD compression on it and we get something pretty small. So this is a very, very powerful technique. There's several encodings. Low cardinality is for strings, and then there's several types of encodings for numeric data types, and they're listed here. One thing to note is the codec compression. When these codecs are applied, you may need to switch to ZSTD because LZ4 sometimes doesn't compress them well. So here's an example of how to do it. You just do an alter table. This is really easy. It can be done instantly. These commands complete instantly. This one's changing tail number to use low cardinality as its as a transformation on strings. This one, slightly different syntax, but taking year and applying a double delta codec. Just store the slope of the slope. This should be pretty efficient. And then compress it with ZSTD1. You have to tell ClickHouse that, hey, I've not only made these changes, but I want you to force them to be materialized. This is the standard way of doing it in most ClickHouse versions. And the difference is pretty can be pretty significant. In fact, it can be phenomenal in some cases. This is the effect of something I was running last night on tail number. So just compressed with uncompressed data. In the table I was using was about a gig. It comes up to it then gets compressed with LZ4 and it's about half a gig, so 450 megs. If I apply low cardinality to it, then the data that goes in is going to be much smaller to begin with, and then I use LZ4 compression, which squeezes out even more, so I've reduced the data to about 40% of its original size. That's pretty good. So we're basically talking a compression rate here of about 80% on these strings. ClickHouse is not bad. There's other things we can do, but this gives you an idea of how we can do this effectively. All right, that's all the tips and tricks for getting started on applications. Let's talk about some, or for ClickHouse itself, let's talk about some information that may help you get started on applications. First of all, if you're building analytic applications, there's definitely some software you need to know about. And I've just listed standard event streaming, ELT, rendering and display, client libraries, as well as Kubernetes software. This is all open source. These are standard, standard components that we see again and again in applications, and that if you're not using them now, you may want to think about them. So for example, on event streaming, I'll just pick one. Vectorized produces Red Panda. It is a Kafka compatible streaming event streaming system. It's very, very efficient. The name Vectorized, it uses vector processing on the data, really screams. Other things, Kubernetes, Altinity does the Altinity operator for ClickHouse. If you're using JavaScript and Node or inside Node, you probably want to look at Appla, so on and so forth. In the slides, you'll have the links. One thing that's important about ClickHouse is because it's open source and a lot of people have worked on it, there are many choices for client libraries and they are not equal. So some of them are just things that people did as a hobby. This list here includes the most popular and most stable versions of all of them. Second thing, where's the documentation? Best source to start with, ClickHouse official docs. They're great. As people always say, hey, I can't believe an open source project has this much documentation. It's very complete. There are things that are not covered well, but by and large, you'll find basic references to everything. To dig deeper, there's the Altinity blog, our YouTube channel, and knowledge base. For example, this class that we're doing is going to go up on the YouTube channel. And then the knowledge base is invaluable. That's our support folks. We have a growing team, and as we run into problems or interesting things, we just pop them into KB articles. Again, it's all out there. It's open source. You can just grab it and try it out. You can also you could actually also submit your own. And then there's a pile of meetups, other blogs, external resources. Just search for them on Google and you'll find them. So these are great sources of information on ClickHouse. Final thing is, where can I get help? Telegram. That's probably the number one place that a lot of people still use. There are two huge Telegram channels. There's one in Russian that has 5,000 or 6,000 members. There's another one in English with at least 2,000 members. The pop-ups that we were seeing were actually coming from Telegram because I failed to turn the notifications off. Another great place is Slack. There's the ClickHouse public workspace. A lot of questions come up there. Altinity has a public workspace. Come visit us. We're happy to help. We spend a lot of time on both of these. You'll meet me on either one. Education. This is an example of ClickHouse Altinity training for ClickHouse. We also have a ClickHouse 101 class that I highly recommend. It goes deep on ClickHouse, everything you would really want to know to build everything from a small embedded application up to clusters with dozens or hundreds of nodes. And then finally, we offer support for ClickHouse in all environments. So with that, we've reached the end. I want to thank you and wish you good luck. Hopefully you will look like this guy who's shown on the right here, only instead of surfing a big wave, you'll be surfing big data. So We hope this class has been helpful. I'll stick around if you have questions. I'm glad to answer them, but best of luck. This has been recorded. We will send a link to the recording as well as to the slides. So I hope you haven't been frantically scribbling notes. If so, you'll also have the slides to go along with them. We'll get them out within 24 hours. So with that, if you have any questions, feel free to pop them into chat or to the Q&A, and I will answer them.